When you're making concrete, you need to use 1 shovelful of cement, 2 of sand, and 3 of gravel. We call this a ratio. If you wanted to make more concrete, you would have to use bigger numbers. So let's say we wanted to use 3 shovelfuls of cement. Then we'd have to use 6 of sand and 9 of gravel. These are equivalent ratios because to get this one, every number here has been multiplied by 3. We call this one the simplest form because the numbers are as small as they can be. So to write a ratio in its simplest form, I need to find the biggest possible number that goes into the numbers in the ratio. In this one it's 5, so if I divide by 5 I get 3, and if I divide by 5 here, I get 5. For this one I can divide by 6, I get 2 and 3. And for this last one I need to divide by 4 to get 1, 3 and 5. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's an exam-style question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. We're now going to look at using ratios to draw plans and maps. In this question, I'm told that a plan of a kitchen is made using a scale of 1 to 10, so this is our ratio here. In the kitchen, the washing machine is 1.3 metres away from the cooker. I want to know how far in centimetres this will be on the plan. The first thing to notice is that I've got metres here and centimetres here. I can't use 2 different units, so I need to change the 1.3 metres into centimetres. I do this by multiplying by 100, so I get 130 centimetres. So now I'm ready to set up my ratio. I've got the plan, and then I've got real life. The ratio is 1 to 10, so it's 1 for the plan and 10 for real life. And in real life, I know that the washing machine and the cooker are 130 centimetres apart. So I need to work out what number goes here. I can see that to get from 10 to 130, I've multiplied by 13. So I need to do the same thing on this side. That gives me 13. So on the plan, they're 13 centimetres apart. Here's one of those for you to try. This time you're told that the cooker and the washing machine are 14 centimetres apart on the plan. Using this ratio, you need to work out how far apart they are in real life. Press pause and have a go. When you're ready, press play. Here's the answer. In this question, we're going to look at using a ratio for the scale on a map. I'm told that the scale on the map is 1 to 10,000. This means that if 2 places are 1 centimetre apart on the map, then they're 10,000 centimetres apart in real life. Frampton is 24 centimetres away from Grimton on the map. I want to know how many kilometres apart they are in real life. So I set up my ratio. I've got the map and I've got real life. The ratio is here, so that's 1 to 10,000. And on the map they're 24 centimetres apart, so this is 24. I can see that to get from 1 to 24, I've multiplied by 24. So I need to do the same thing to this number, multiply by 24. That gives me 240,000. Now this means that in real life, Frampton and Grimton are 240,000 centimetres apart. I've got to change this into kilometres. So 240,000 centimetres can be divided by 100 to give metres, and that's going to be 2,400 metres. Now the metres, 2,400, can be divided by 1,000 to give kilometres. So that's 2.4 kilometres. So the answer to the question is 2.4 kilometres. For part B, I start in the same way by setting up the ratio. Now I'm told that Acton is 8 kilometres away from Bicton in real life, and I want to know how many centimetres they will be apart on the map. I've got to change my unit here because this is kilometres and this is centimetres. So I'm going to change 8 kilometres into centimetres. I can multiply by 1,000 to get metres, so it's 8,000 metres, and then I can multiply that by 100 to get centimetres, so that's 800,000 centimetres. So in real life, Acton and Bicton are 800,000 centimetres apart, and I want to work out the number here. I can see that to get from 10,000 to 800,000, I've multiplied by 80. So I need to do the same thing here, multiply by 80, and I get 80. So on the map, they are 80 centimetres apart. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here we've got a list of ingredients for making apple crumble for 4 people. Jenna doesn't want to make apple crumble for 4 people though. She wants to serve 10 people, so she's going to have to change the amounts of each ingredient that she uses. Now there are lots of ways to work out how much of each ingredient she needs to serve 10 people. We could work out the amount for 1 person. We'd do that by dividing by 4. We could then multiply by 10 to work out the amount for 10 people. So this is one method of getting the answer. Another way would be to say that this recipe serves 4 people. But we want to serve 10, so we'd need another 4 people to make 8, and then another 2 people to make 10. So we'd need the whole recipe twice, and then half of the recipe. The way I like to do this question, especially if it's on the non-calculator paper, is to say it's easy enough to work out how much of each ingredient we need for 2 people by dividing by 2, and once I know the amounts for 2 people, I can multiply by 5 to get the amounts for 10 people. So this is my plan. I'm going to divide each amount by 2 and then multiply by 5. So first of all, I want to divide the amounts here by 2. So 80 divided by 2 is 40. 60 divided by 2 is 30. 90 divided by 2 is 45. 60 divided by 2 is 30. And 4 divided by 2 is 2. Now I need to multiply all of these by 5. So 40 times 5 is 200. 30 times 5 is 150. 45 times 5 is 225. 30 times 5 is 150. And 2 times 5 is 10. For any difficult multiplications, like 45 times 5, if you need to do a bit of side working, that's absolutely fine. The working would look like this. To finish off, we just need to label our quantities with the names of each ingredient. So this is the final answer. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Part B is a bit different. Take your time to read it carefully. Press pause and have a go. When you're ready, press play. Here are the answers. One way of getting this answer for Part B is to say that 120 grams of flour makes 8 pancakes. 60 grams is half of this, so that will make half of 8, which is 4 pancakes. Zoe uses 180 grams of flour, which is these two amounts added together. So she must make these two amounts of pancakes added together, which is 12. Here's your final, difficult exam question to try. Press pause and have a go at it. When you're ready, press play. Now, every time Richard makes this recipe, he uses up 25 grams of sugar. If he's got 250 grams of sugar, that means he can make the recipe 10 times. The recipe uses up 100 grams of butter each time, so with 900 grams of butter, he can make the recipe 9 times. If I do the same thing for the flour, I first of all need to change this 1 kilogram into 1,000 grams. Now 100 grams goes into 1,000 grams 10 times, so he can make the recipe 10 times with the flour he's got. And for the milk, 5 goes into 30 6 times, so he can make the recipe 6 times with the amount of milk he's got. Now obviously, we need to decide which of these ingredients is going to run out first, and it's going to be the milk, because Richard can only make the recipe 6 times before he runs out of milk. If he makes the recipe 6 times, he's going to make 6 lots of 6 biscuits. So the amount of biscuits he can make is 36. Once he's made 36, he's run out of milk, so he can't make any more. So the answer to the question is that Richard can make 36 biscuits. You're probably familiar with the word percent, but where does it come from? Now you should know what per means, and cent actually means 100, so per cent means per 100. To help you remember that cent means 100, you can think about American dollars. They're split into cents, and there's 100 cents in a dollar. You might also know that a century is 100 years. Now the percent sign actually looks like this, and this helps you remember that percent is something to do with 100, because you can see the 1 and the 2 zeros here. Now in this question, I'm asked what fraction of this 100 square grid is shaded. I can see here that I've got 9 little squares shaded in, so that is 9 out of 100, written as a fraction. Now if I change the question slightly and say what percentage of this 100 grid is shaded, I've got 9 per 100 here, and we know that that's 9% because percent means per 100. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now in this question, I'm asked again what percentage of the grid is shaded, but the grid doesn't have 100 squares in it this time, so how do I deal with it? Well, I can see that I've got 4 squares shaded per 10 squares because there's 10 squares altogether. Now to turn this into a percentage, the number on the bottom needs to be 100. How do I get from 10 to 100? Well, I multiply by 10. So I'm going to do the same thing to the top, multiply by 10. 4 times 10 is 40. So this is 40 per 100, which is 40%. Here are 2 for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a slightly more difficult question for you now. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a more challenging question for you now. Press pause and have a go. When you're ready, press play. Now, there are a few different approaches to this question. I'm just going to show you one. Finding the amount of squares shaded in this triangular shape is quite tricky, but if I just look at the surrounding rectangle, I can see that that's exactly 10 squares, and the triangle is half of that. So there must be 5 squares shaded in the triangle. So we've got 5 squares shaded, and in the total picture, there are 25. To turn this into a percentage, I want this to be 100 on the bottom, so I multiply that by 4. I multiply the top by 4 as well. 5 times 4 is 20, so 20% of the grid is shaded. In this question, I'm being given the prices of 2 different packs of pens, and I want to work out which one is the best value for money. To do this, we always divide the money by the amount of things in the pack. So for the first pack, I've got £1.50 divided by 3. That is 50p. So the pens are 50 pence each. In the second pack, I've got £2, and I'm dividing this by 5 this time. That's 40p. So the pens are 40p each. So the one that's the best value for money is the one where the pens are cheaper, and that's this one here. So my pack of 5 pens is the best value for money. So to find the best value for money, I always do money divided by quantity and then compare the values to look for the smallest one. This is a harder question, but you would be allowed a calculator to do this one. We approach it in the same way. So the money here is £1.68 and the quantity is 350. Dividing this with a calculator gives me 0.0048. This is the price per gram, but we don't really need to worry about that. For the second one, we've got £2.47 divided by 475. Using a calculator again, I get 0.0052. Again, this is the price per gram, but all I want to do is compare these two. I can see that this one is the smallest, so the first bag of popcorn must be the best value for money. So here's my answer. Remember, the question asks you to show all your working, so this is absolutely vital to get the marks. You also mustn't forget to write your conclusion. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. The 7 kilogram bag is the best value. Here's another question for you. Be careful with this one. The price of this bag is given in pence, whilst this one is given in pounds. To make the question work, you need to either have them both in pence or both in pounds. Press pause and have a go. When you're ready, press play. Here's the answer. Your working will look like this if you worked in pennies, or like this if you worked in pounds. You still get the same conclusion either way. Here's your final question. Again, you need to be careful with this one. Here, the amount of crisps is given in grams, and here it's given in kilograms. So you either need to change them both to grams or both to kilograms before you begin. Remember, there are 1,000 grams in a kilogram. Press pause and have a go. When you're ready, press play. Here's the answer. Your working out will look like this if you worked in grams, and like this if you worked in kilograms. Your conclusion is this. I'm told here that Anna made 4 scarves after knitting for 2 hours. I want to know how many scarves she could make if she knitted for 6 hours. So, in 2 hours, she managed to make 4 scarves. And I want to know how many she made in 6 hours. Now I can see that the amount of time has multiplied by 3, so the amount of scarves is going to multiply by 3 as well, and we end up with an answer of 12 scarves. In part B, I want to know how many scarves she could make if she knitted for 9 hours. I start in the same way. In 2 hours, she can make 4 scarves, and I want to know how many scarves she makes in 9 hours. But I can't easily get from 2 to 9, so what I'm going to do is work out how many scarves she can make in 1 hour. So from 2 to 1, I've halved the amount of time. So I'm going to halve the amount of scarves and get 2 scarves. And then from 1 hour to 9 hours, I've multiplied by 9, so I do the same thing over here. 2 times 9 is 18, so the answer is that she can make 18 scarves in 9 hours. So when you're dealing with this type of proportion question, if there's an easy link between the number you're given and the number you want, then you can do it in one stage by multiplying or dividing. If there isn't a straightforward link, then we do it in 2 stages by first of all getting to 1 and then getting to the number that we want. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now this is a slightly different type of question. I'm told that James walked a total of 6 miles by making 2 trips to school, and I want to know how many trips he has to make to walk 15 miles. So I start with 6 miles, and he does this in 2 trips. Now remember, I want 15 miles. There's no quick link between 6 and 15, so in the middle here, I would normally go to 1 mile, and I would get there by dividing by 6. But we meet a problem. If we try to do 2 divided by 6, we end up with something really difficult. So I'm going to try a different approach to this question by reversing it. What I mean by reversing it is that I'm going to do my working out on this side instead of this side, because I can easily get from 2 trips to 1 trip. I would do that by dividing by 2. If I do the same thing over here, I get to 3 miles. So 3 miles is 1 trip. Now I can get from 3 miles to 15 miles by multiplying by 5. I can do the same thing over here and find that it's 5 trips. So my answer is 5 trips. And I had to be a little bit flexible to get this. I started working over here and then switched and worked over here. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. This question could be on the calculator paper. We still approach it in the same way. 5 apples cost £1.25. We want to work out the cost of 7 apples. There's no nice link between 5 and 7, so first of all, I work out the cost of 1 apple. And I do that by dividing by 5. So I can type this into my calculator and divide it by 5. I get 25 pence. So each apple is 25p, and I want to know the cost of 7 apples. I do that by multiplying by 7. And I get £1.75. So the answer to this question is £1.75. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. I'm going to start this question in the same way as before. I'm told that one person can paint a fence in 4 hours. And I want to know how long it would take 2 people. Now it's really tempting to say we've multiplied by 2 over here, so we multiply by 2 over here. But hang on a moment and think. If they're painting a fence and there's 2 of them and they help each other, it's going to take less time, not more time, so we don't want to double this. Instead, if we times by 2 over here, we divide by 2 over here. And we get that it will take 2 hours. It's called inverse proportion because if I multiply on this side, I do the inverse, which is division, on this side, and vice versa. If I divide over here, then I multiply over here. So in the same way here, I'm told that 3 people can dig a trench in 3 hours. So 3 people take 3 hours. And I want to know how long it would take 1 person. So on this side, I'm dividing by 3. Now, if 3 people dig a trench in 3 hours, it's going to take 1 person much longer. So instead of dividing, I have to do the inverse, which is multiplying. So I multiply by 3, and I get the answer 9 hours. Now for part B, I want to know how long it would take 2 people. Remember, in part A, I've already worked out how long it would take 1 person, and that's 9 hours. I want to know how long it will take 2 people. So this has been multiplied by 2, but that means that the time over here is going to divide by 2. So we have 4.5 or 4.5 hours. Here are some of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. In this question, we're going to look at exchange rates. We're told that £1 is equal to $1.67. We want to know how many dollars we would get for £150 and how many pounds we would get for $120. So for this first part, I know that for every pound I get $1.67. So for £150, I'm going to get 150 times the $1.67. This type of question is usually on the calculator paper, so you can use a calculator to do this. You get the answer $250.50. If we want to change dollars into pounds, instead of multiplying by 1.67, we need to divide by 1.67. Again, we use a calculator and we get £71.86 rounded to the nearest penny. Now, in an exam situation, a lot of people get muddled up between when they times and when they divide. The way I like to remember it is when you're going on holiday, you're going to have a nice time. So when you're changing into your holiday currency, you times, and when you're coming home, you divide. Here's a question for you to try now. Remember, when you're going on holiday, you're going to have a nice time, so you times, and when you're coming home, you divide. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. You'll notice that on this one, I needed to round my answer to the nearest penny. This is a typical exam-style question now. There's lots of words here, but the important thing to look for is the exchange rate. Remember, when you're going on holiday, you're going to have a nice time, and when you're coming back, you need to divide. Now, Jim goes on holiday to Hong Kong. He sees a smartphone costing this much money, and he buys the smartphone. What we want to know is how much cheaper the smartphone was in Hong Kong than it would have been in London. So we know he paid this much money in Hong Kong dollars. We want to change the dollars into pounds, so we've got to divide. Using a calculator and rounding to the nearest penny, we get £430.51. So this is how much the smartphone actually cost him in Hong Kong. Now, to find out how much cheaper the phone was in Hong Kong than in London, I need to get the price in London, which is £549, and take away the price that he paid in Hong Kong. Again, we can use a calculator, and we get £118.49. So the smartphone was this much cheaper in Hong Kong than it would have been in London. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. The difference in price is £4. Here's your next question. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, you need to change £300 into Eastern Caribbean dollars, then work out how many 20s will go into this by dividing. He can't get 67.8 notes, so he's just got to get 67. Finally, here's a really difficult exam-style question for you. The advice I'm going to give you is that you know the price in pounds per litre in the UK, so it would make sense to change this into pounds per litre so that you can compare the two prices. If you don't have much success, don't worry, I am going to go through this one with you. Press pause and have a go. When you're ready, press play. So remember, in the UK, we've got the price in pounds per litre, so I want to change this into pounds per litre. I know that 1 US gallon is 3.79 litres, so I can do this straight away. Now I want to change the dollars into pounds. Here's the exchange rate. Remember, this way is times, and this way is divide. If I'm changing dollars into pounds, I need to divide by 1.47. So I have this divided by this. Using a calculator and rounding to the nearest penny, I get £2.45. So in the USA, the petrol is £2.45 for 3.79 litres. But I want the price per 1 single litre, so what I need to do now is divide by 3.79. Again, I can use a calculator, and I get 65 pence to the nearest penny. So in the USA, the petrol is 65 pence per 1 litre. Comparing this with the price in the UK, it's nice and quick now to see that the USA is much cheaper. So our conclusion is that the petrol is cheaper in the USA. So my conclusion is that in the UK, the petrol was £1.30 per litre. In the USA, it was 65 pence per litre, so the USA is cheaper. There are two main types of ratio question. Types where you're sharing something out, and ones like this one where you're not sharing out. We start each one in the same way. We need to write down our ratio. In the first question, I've got the ratio 3 to 5. I've also got the names Alice and Brett. These will be in the same order as the ratio appears, so I'm going to put labels on here, A for Alice and B for Brett. I'm being told to share out £40, so I'm going to put that here. This tells me how many shares I've got altogether. So I've got 3 plus 5, which is 8. So I'm sharing £40 into 8 equal pieces. That's 5. Alice gets 3 of these shares, so she gets 3 times 5. And Brett gets 5 of the shares, so he gets 5 times 5. So Alice gets £15 and Brett gets £25. So to summarise, I see how many shares I've got altogether, that's 8. I divide the money, which gives me £5 per share. So Alice is getting 3 lots of £5 and Brett gets 5 lots of £5. I start this type of question in the same way, by writing down my ratio. This time, the ratio is 5 to 2. I've got my names here, Tom and Joe. Remember, they're in the right order, so this is Tom and this is Joe. I now need to read the question carefully. I'm told that Tom received £15 in tips. So this time I'm not sharing anything out, but I know that Tom got £15. So I put that in the Tom column. What I want to do is work out how much Joe got, so I'm looking for the number that would be here. For Tom to get 5 shares and for it to equal £15, each share must be £3. So I multiplied Joe's 2 by 3 to give £6. So the answer to the question is that Joe received £6. Just out of interest, if you're ever stuck on what you multiply this by to get this value here, you can always divide this by this to give you what you're multiplying by. Here are 2 questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are 2 more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a very difficult exam type question for you to try. Press pause and have a go at it. When you're ready for the answer, press play. After reading this question through, I can see that the maths of it isn't difficult, but making sense of it is, so I'm going to use the line-by-line approach. This first line just gives me a bit of information, but I can't do any maths with it, so I move on to the next line. Again, no maths in this line, so I move on. Again, just information in this line, but nothing to do with it, so I move on. Aha! This line looks like maths to me. I've got the word ratio here, and I've got a ratio. I'm given 1 to 2, and I know that this is boys and girls. And in the line above, I'm told that the university sent 16 boys, so I can put this in the boys column. Now from this, although this line hasn't actually asked me to do anything else, I know that I can work out how many girls the university sent. Here, we've multiplied by 16. So if we do the same thing here, we get 32. So we know that the university sent 16 boys and 32 girls, and that means that it sent 48 students altogether. The next line gives me information, but no maths again. But this is a really important line. It tells me that each of the 5 universities sent the same number of students. I've already worked out that one of the universities sent 48 students, so I know that the total number of students is going to be 5 times 48. This is 240. Obviously, if you find this difficult to do in your head, you can always set it up. Like this. The final line of the question asks me to work out the total number of students sent to the conference by the 5 universities. I've actually already worked this out. The answer is 240. So my final answer is that the total number of students sent to the conference was 240. Here's another difficult exam-style question for you to try. Notice that this one has an asterisk next to it. This means that the examiner will be looking at the quality of your working out. Press pause and have a go. When you're ready, press play. This question is quite difficult again, so I'm going to use the line-by-line approach. No maths in the first line, so let's look at the second line. Aha! The second line gives me a ratio that I can set up. So the ratio is 1 to 3 to 5, and this is cement, sand, and gravel. This line tells me that Beth wants to make 180 kilograms of concrete mix, so this is a sharing out question. So the total number of shares is 1 plus 3 plus 5, that's 9, and I want to share 180 between 9. That gives me 20. Remember, if you find this division difficult, you can always set out a working. Like this. I can now multiply each of these by 20. So for Beth to make 180 kilograms of concrete, she will need 20 kilos of cement, 60 kilos of sand, and 100 kilos of gravel. The next line of the question tells me that Beth has got 15 kilograms of cement. I can see that 15 kilograms is not enough to make 180 kilograms of concrete because she needs 20 kilograms of cement. So she's 5 kilograms of cement short, so she doesn't have enough cement. She's got 85 kilograms of sand and she needs 60 kilograms of sand, so she's definitely got enough sand. And she has 100 kilograms of gravel, and she needs 100 kilograms of gravel, so she's got exactly the right amount of gravel. Finally, the question asks me, does she have enough of each to make the concrete mix? And the answer is no, she doesn't have enough cement. So here's my answer. Notice that to get full marks, because this question has an asterisk, I've shown clear working all the way through, and I've finished with a concluding statement. Here's your final difficult exam-style question to have a go at. Press pause and try it. When you're ready, press play. Here's the final answer, and here's the working for that answer. I'm going to show you how I got this using the line-by-line approach. So the first line doesn't give me any maths to do. But as soon as I've got the second line, I can work out how much Tom gets per day by doing 8 times £8.50. This line gives me a ratio to use. So I've worked out that Tom gets paid £68 per day, and I want to share this in the ratio 4:1. I'm allowed a calculator on this question, so the working out is fairly straightforward with a calculator. Tom gets £54.40 and Sue gets £13.60 each day. I've got information here, but no maths. And now I have a question. I want to know how many days it will take Tom to save £1,360. Remember, I know that Tom is getting £54.40 each day. If I divide £1,360 by £54.40 using my calculator, I get the answer 25. So it will take Tom 25 working days to save up this amount of money. I'm told that in a class the ratio of left-handed pupils to right-handed pupils is 2 to 5. This means that there are 2 left-handed people for every 5 right-handed people. One way to think about this is that this is a tiny little class with only 2 left-handed people and 5 right-handed people in it, so there's only 7 people in the class altogether. I'm asked what fraction of the class are left-handed. I can see that in my pretend tiny class there are 2 left-handed people out of a total of 7. So this is the fraction of the class that are left-handed. For the fraction that are right-handed, there are 5 that are right-handed out of a total of 7 again. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a slightly different question. I'm told that the ratio of x to y is 1 to 2. So this is x and this is y. I want to find out which of these statements is correct. So let's have a look at them. The first one says x is a third of y. So let's look at these numbers. Is 1 a third of 2? Well, no, it's not, so that's not correct. The next statement says y is half of x. Again, let's look at the numbers. Is 2 half of 1? Nope, that's not correct either. Let's look at this one. X is half of y. So is 1 half of 2? Yes, it is. That's correct. I'm just going to check this last one as well. It says y is 2/3 of x. So is 2 2/3 of 1? No, definitely not. So this is the correct statement. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. You'll notice this time that it says which of the following statements are correct. That tells you that there's going to be more than one correct statement. Press pause and have a go. When you're ready, press play. Here are the answers. You'll see that we've got 2 correct statements this time. For this first one, we needed to work out what a plus b was, and a plus b is 9. Now, is a, which is 2, 2/9 of 9? Yes, it is, so the first one's correct. And this one is also correct. This is a different type of question. I'm told that miles can be converted to kilometres using the ratio 5 to 8, and I'm being asked to draw a conversion graph to illustrate this. The first thing I'm going to need is a set of axes. Now I'm converting miles to kilometres, so I'm going to label this axis miles and this one kilometres. Now in our ratio, this is miles and this is kilometres. So I need to go to 5 on the miles axis and to 8 on the kilometres axis. So I've got the point 5, 8 and I can plot that. I also know that 0 miles would be 0 kilometres, so I can plot that point as well. Now to draw my conversion graph, I need a line that goes through these 2 points. When I draw my line, I make sure to extend it to the end of the squared paper. Now to finish off, I just need to continue labelling my axes. So on the miles axis, we're going up in 5s, so that's 10, 15, 20, and that would be 25. And on the kilometres axis, we're going up in 8s. So this would be 16, and I can't fit any more on. This is my finished conversion graph. Now I've got 2 questions here that I can use my conversion graph to help me with. I want to convert 11 miles to kilometres, so I find 11 on the miles axis. That's here. I draw a line straight up until I meet my conversion graph. Once I meet the graph, I then go straight across to the kilometres axis. And I now need to read off how many kilometres this is. I know this is 16, so this would be 17 here, so this is 17.5. So the answer is 17.5 kilometres. Now for this one, I'm asked to convert 30 kilometres to miles. So I'm looking for 30 on the kilometres axis. Now we've got a problem here because it doesn't go up to 30, so I need to find another number I could use. Half of 30 is 15, and it does go up to 15, so I'm going to use that and then double it to get 30. So I'm going to go across from 15 until I meet my conversion graph. Then down until I meet the miles axis. Now I need to read off how many miles this is. It's between 9 and 10 and it's in the middle, so it must be 9.5. So I know that 15 kilometres is 9.5 miles. But I want 30 kilometres, so I'm going to double this. And double this, which is 19. So 30 kilometres is 19 miles. So this is my answer. It's helpful to remember that in an exam, whenever you're answering questions based on a hand-drawn graph, the examiners will give you a bit of leeway in your answers. So don't worry if you try this yourself and don't get exactly 17.5 and 19. You'll be allowed answers that are close to these values. Here's one for you to try. You'll need some squared paper for this one. Press pause and have a go. When you're ready, press play. Here are my answers. Your conversion graph might look slightly different to this, but you need to make sure you've gone through the points 0, 0 and 5, 2. You might have slightly different answers for these questions as well, but remember there's always a bit of leeway when we're dealing with a hand-drawn graph. Here's another one for you to try. Part of the conversion graph has been drawn for you this time. Press pause and have a go. When you're ready, press play. Here's my answer. Your conversion graph might look slightly different, but you should have a similar answer to the answer I've got here for part B. In this question, I'm being asked to find the total cost of the sofa. I'm told that the sofa is £362 plus the VAT at 20%. So what I need to do is find 20% of £362 and add it on. I'm going to start by finding 10% of £362. I do this by dividing by 10. And I get £36.20. 20% will be double this. Doubling this in my head gives me £72.40. If you find doubling this in your head difficult under exam conditions, you can always set it out as a piece of side working. Like this, or even like this. So now I have my 20%, I just need to add it on to the £362. So I've got £362, add £72.40. I get £434.40. So this is my final answer. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Now here's a typical exam question for you to try. This one's quite difficult, so I'm going to give you some hints. The first thing you need to do is find 20% of £8,000 and add it on. Now, when the question says that she pays £4,000 deposit, that means that Sue is paying this money up front. The remaining money that she's got to pay for the car is called the balance. Press pause and have a go at this now. When you're ready, press play. Here's the answer. To get this, I found 20% of £8,000 and I added it to get £9,600. I knew that Sue was paying a £4,000 deposit, so I subtracted this to leave me the balance, which is £5,600. I'm told she pays 10 equal monthly payments, so I divide the balance by 10 to get each monthly payment of £560. In this question, we're allowed to use a calculator. We can do this question in two different ways. For the first method, we need to find 12% of £45 and add it on. 12% is 12 over 100. Of £45 means I multiply by 45. I can type this into the calculator as 12 divided by 100 times 45, and this gives me £5.40. To get the final answer, I need to add the £5.40 onto my £45. I get £50.40. So the final answer is £50.40. The other way to do this question is to think of the £45 as being 100%. And we want to add on 12%. So that gives us 112%. So what we want to find is 112% of £45. To do this, we have 112 out of 100 times 45. Typing this into the calculator as 112 divided by 100 times 45 will give us the answer straight away. We get £50.40. So the answer is £50.40. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the two different ways that you could have got this answer. Here's another question for you to try. This time the price has been reduced, so you need to find 18% and take it away from £7,500. Press pause and have a go. When you're ready, press play. Here are the two different ways of getting the answer. If you were using this second method, I hope you realised that you needed to take the 18% away from the 100% to get 82%, and then carry on in the normal way. Here are your final two questions. Press pause and have a go at them. When you're ready, press play. Here are the answers. Again, for both of these questions, I've shown you two methods of getting the answer. A typical question you might come across on an exam looks like this. I'm being asked to find a percentage increase. This kind of question is straightforward as long as you can remember these two formulas here. For a percentage increase, you work out the actual increase, divide it by the original value, and then multiply by 100. Percentage decrease is very similar, but you work out the actual decrease instead of the increase. So to answer this question, the first thing I need to do is work out the actual increase in price. It's gone from £7.50 to £9. So to get the increase, I do £9, take away £7.50, and that's £1.50. I divide this by the original price, and the original price was £7.50. And I multiply by 100. I can use a calculator and I get the answer 20%. So there's been a 20% increase in the price of the ticket. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. This time it's asking you for the percentage profit. You work this out in the same way as you'd work out a percentage increase. Press pause and have a go. When you're ready, press play. Here's the answer. This time I'm being asked to calculate the percentage reduction, so this is a percentage decrease. I work out the actual decrease first of all, so that's 275 minus 242, and that gives me 33. I put this over the original price. Now the original price here was 275, and I multiply by 100. This gives me 12%. So there's been a 12% reduction in the price of the fridge. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's a more difficult question for you to try. Press pause and have a go. When you're ready, press play. So in this question, I'm told that the length of the rectangle is increased by 10%. 10% of 20 is 2, so we've got 20 plus 2, and the new length is now 22 centimetres. The width is increased by 20%. 20% of 10 is 2, so we've got 10 plus 2, and the new width is now 12 centimetres. I want to find the percentage increase in the area of the rectangle. So I need to find the original area first of all. The original area is 20 times 10, which is 200. The new area is 22 times 12, and that's 264. So the increase is 264, take away 200, which is 64. I need to work this out as a percentage of the original area. So I've got 64 over the original area, which is 200, and I want to times that by 100. And that comes out to be 32%. Here's your final question. Press pause and have a go at it. When you're ready, press play. Here's the answer. Now that was a really difficult question, so I'm going to take you through it. We know that Jane made 720 biscuits. She sold 70% of them at 25p each. So I've got to work out 70% of 720. I do that by dividing 70 by 100 and timesing by 720, and I get this. Now those biscuits are 25p each, so I multiply by 25p and I get 126. So that's £126 from those biscuits. I'm told she sold the other 30% at 4 biscuits for 60p. So I need 30% of 720. Again, that's 30 divided by 100 times 720. That's 216. Now she's selling them at 4 for 60p. So I need to work out how many groups of 4 are in here. So I divide by 4 to get 54. So there's 54 groups of 4 biscuits. They're 60p per group. And that works out to be £32.40. So she made £126 plus £32.40, that's £158.40 altogether. The biscuits cost her £40 to make, so I take that off, and she's got a profit of £118.40. Now that's her actual profit. I want to work out her percentage profit. So now, to work out the percentage profit, we're back to our formula. We've got the actual profit, that's £118.40, over the original price, that's what it cost her to make the biscuits, so that's 40, and we times that by 100. It comes out as 296%, so she's made 296% profit. That tells you that the amount of money that she made as profit is nearly 3 times as much as the money she spent making the biscuits. I'm told that in a sale, normal prices are reduced by 10%, and Dave bought a camera in the sale for £180. I want to work out the original price of the camera. Now, the original price of the camera must have been 100% of its price. In the sale, it's been reduced by 10%, so I take this away, and that tells me that Dave paid 90% of the original price for the camera. Now, this 90%, we know, was £180. What we want to do is work out 100%. So to help me get from 90% to 100%, I'm going to work out 1%. To get from 90 to 1, I divide by 90. So I'm going to do the same thing on this side. £180 divided by 90 is £2. Now to get from 1 to 100, I multiply by 100. So I do the same to this side. £2 multiplied by 100 is £200. So the original price of the camera must have been £200. Now, the most common mistake that people make when trying this type of question is to find 10% of this number and add it on. This doesn't work, however. The key thing to these questions is spotting the type of question it is. We call them reverse percentage questions. You can spot them because you know that everyday life things start off at 100%. But in our question, we're not given 100%. In this particular question, we're actually given 90%. So we need to reverse things to get back to the 100% that we actually want. Now, these questions are quite difficult, so I'm going to go through another example with you. First of all, we need to spot that it's a reverse percentage question. We do that because we can see that the price has been reduced by 15%, so this price here is not 100%. So, 100% is what we'd start off with, and we're taking away 15%. So that gives us 85%. So this price here is actually 85%. We want to work out 100%. And to do that, we're going to get 1%, and we get that by dividing by 85. We will also divide by 85 on this side. So using a calculator, 51 divided by 85 gives me 0.6. So that's 0.6 pounds, which is actually 60 pence. Now to get from 1% to 100, I times by 100, so I do the same thing over here. 60 pence multiplied by 100 is 60 pounds. So the original price of the coat was £60. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now this question is a little different. In Italy, Lance spends €2.80 on pizza. I'm told that this price includes VAT, which is 12%, and I want to work out how much the VAT actually was. Now, this amount of money here is not 100%. It's 100% plus the 12% because it's got that VAT included in it. So this amount here represents 112%. Now I do this in the same way as the previous questions. So we've got 112%, and that's €2.80. I want to actually know what 100% is. So I work out 1%, and I do that by dividing by 112. I divide by 112 over here as well. Using a calculator to do this division, I get 0.025. Now to get 100%, I multiply by 100, and I do the same thing over here. And that gives me €2.50. Now we need to read the question. The question actually asks for the amount of VAT. So I now know that €2.50 is 100%, and I also know that 112% is €2.80. I want to work out how much the 12% was. Well, we've gone from €2.50 to €2.80, so it's a fairly straightforward calculation to work out that it's 30 cents. So this is the amount of VAT that Lance paid. Here's a question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. The trick here was to notice that the percentage given is 22.5%, and this is 146 MPs. We can then divide by 22.5 to find 1% and multiply by 100 to find 100%. Here I've rounded the number to the nearest whole number. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at simple interest. Before we do this, we need to remind ourselves how to find a percentage of an amount. This is non-calculator, so I start by finding 10%. To find 10%, I divide by 10. £200 divided by 10 is £20. Now I want 5%, and 5% is half of 10%, so I halve the £20 and get £10. So 5% of £200 is £10. I'm going to do this one in a similar way. So I start by finding 10%, and I do that by dividing by 10, so I get 400. Now I want 3%, so I'm going to find 1% now. To get from 10% to 1%, I divide by 10, so I divide this by 10 and get £40. Now I can work out 3% by timesing this by 3. So I multiply this by 3 and get 120. So 3% of £4,000 is £120. So this is a simple interest question. I'm told that Bill has £200 in his savings account and that the account pays 5% simple interest per year. I want to work out how much interest he will earn in 3 years. So the first thing I need to do is find 5% of £200. So remember, we start by finding 10%. 10% of £200 is £20. 5% is half of that, so that's £10. So in each year, he's going to earn £10 interest. He's leaving the money in the bank for 3 years, so I'm going to multiply this by 3. 3 times £10 is £30. So in 3 years, he earns £30 interest. This is a slightly different question. I'm told that Ben borrows £4,000 at a simple interest rate of 3% per year. He's going to pay the money back after 2 years, and I need to know how much he has to pay back in total. So first of all, I want to work out 3% of 4,000. So I start with 10%, and I get that by dividing by 10, so that's 400. Then 1%, so I divide this by 10, which is 40. and then 3%. So I multiply by 3 to get 120. He's paying the money back after 2 years, so I've got 2 times 120, and that's £240. But this question asks how much he's got to pay back in total. He's got to pay back the money he borrowed and the interest. So the total he has to pay back is £4,000 plus the £240. So that's £4,240. The reason this is called simple interest is because you work out the interest for 1 year and then simply multiply by the number of years. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Be careful with the number of years that Katie is borrowing the money for this time. Press pause and have a go. When you're ready, press play. Here's the answer. The key here was to realise that 6 months is half a year. Here's a more challenging question for you to try. In this one, per annum is another way of saying per year. Press pause and have a go. When you're ready, press play. So in this question, we know that Sam earned £24 in 3 years. So the first thing to do is work out how much he earned per year. So I'm going to get my £24 and divide it by 3. So he's earning £8 per year. Now I need to work out what percentage of £400 this actually is. I do that by putting the 8 over the 400. To turn it to a percentage, I need the bottom number to be 100. So I divide by 4. I do the same thing to the top number, and I get 2. So it's 2 out of 100, and that's 2%. So the simple interest rate is 2%. Typical types of measure would be mass, which is measured in grams and kilograms, and distance, which is measured in millimetres, centimetres, metres, and kilometres. However, we also have compound measures. An example is density. Density is usually measured in grams per centimetre cubed. For instance, if you took 1 cubic centimetre of a brick, it would be heavier, it would weigh more grams, than 1 cubic centimetre of a sponge. Another compound measure is speed. If you were running a race, you would measure your speed in metres per second. If you were driving somewhere in a car, you would measure your speed in kilometres per hour. So for simple measures, the units are always straightforward, for example grams or centimetres. For compound measures, the units are a bit more complicated. They're usually something per something else, grams per centimetre cubed, kilometres per hour. Let's look now at how we calculate using compound measures. If we start with density, we can see that this is measured in grams per centimetres cubed. This sign here is really a divide. So whenever we want to calculate a density, we get the grams, that's the mass, and divide by the centimetres cubed, that's the volume. Knowing this, I can draw a formula triangle, and I can use this to calculate density, mass, and volume. For example, if I wanted the density, then that's the mass on top of the volume, and that means divide. So it's the mass divided by the volume. If I want to find the mass of something, then it's the density times the volume. And if I want to find the volume of something, then it's the mass divided by the density. One way I remember this formula triangle is don't move Vera. In a similar way, we can link speed, distance and time using this triangle here. I remember this one by remembering that sausages don't talk. So let's look at some questions on this now. In the first question, I'm being asked to calculate the density of something, so I know that I need my formula triangle. Remember, it's don't move Vera. Now, in the question, I'm being asked to find the density, and I'm being told the volume is 270 centimetres cubed, and the mass is 3,078 grams. So to calculate the density, I need to do the mass divided by the volume. So the density will be the mass, which is 3,078, divided by the volume, which is 270. I can use a calculator to do this, and I get the answer 11.4 grams per centimetre cubed. The last thing I'm going to do is just check that I've given this in the correct units. I'm asked for grams per centimetres cubed, and I've got grams per centimetres cubed. For the second one, I'm being asked to calculate a mass, so I know I need the same formula triangle. It's the mass I'm trying to work out. I'm told that the density is 7.5 grams per centimetre cubed, and the volume is 14,000 centimetres cubed. I'm being asked to calculate the mass, so this is the density multiplied by the volume. So the mass is 7.5 multiplied by the volume, which is 14,000. Again, I can use a calculator to do this, and I get 105,000. Now I need to work out what units this is in. The 7.5 was in grams per centimetre cubed, and the 14,000 was in centimetres cubed. So this must be in the grams part. If I look at the question though, I can see that I want my answer in kilograms. I know that there's 1,000 grams in a kilogram, so I divide this by 1,000 and get 105 kilograms. This is my final answer. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a much more difficult exam-style question for you. I'm going to give you some help for this one. You're being told the density of some metal, and you want to calculate the mass of this prism. So we're given the density, and we want to calculate the mass. That means we need to start by finding the volume. To find the volume of this, you need the area of a trapezium at the front. That's given by this formula. To find the volume, you need to multiply it by the length of the prism. Once you've done this, you can go back to your formula triangle and calculate the mass. Press pause and have a go. When you're ready, press play. So you should have started by finding the area of this trapezium here. You should have got this. You then need to multiply this by this length here to find the volume of the whole prism, and that's this. Now we know that the density is 6 grams per centimetre cubed, and we know that the volume is 600 centimetres cubed, so we can multiply these together to get the mass. Our answer is in grams, but the question asks for kilograms, so remember to divide by 1,000. This is the final answer. Now let's look at some questions involving speed. In this question, I'm being asked how many kilometres the scooter has travelled, so I'm looking for a distance. So I know I need my formula triangle. I remember sausages don't talk. I'm told that the speed is 30 kilometers per hour. I'm told that the scooter travels at this speed for 20 minutes, so the time is 20 minutes. I want to calculate the distance that the scooter has travelled. Now, if I tried to do this straight away using these numbers, I wouldn't be able to get the right answer, because this is in kilometers per hour, but this is in minutes. I need to have matching units, so I need to change this 20 minutes into hours. I know that there are 3 20-minute sections in 1 hour, so 20 minutes must be a third of an hour. Now I can do this. To calculate the distance, I need to do the speed multiplied by the time. So the distance is the speed, which is 30, multiplied by the time, which is 1/3. This gives me 10, and the units for this are going to be kilometres. Here are 2 questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For the second question, I hope you realised that 3 hours and 30 minutes is 3.5 hours, which we can write as 3.5. Using this, we'll get the right answer. Finally, here's another difficult exam question for you. For this one, you need to calculate the total time it would take to travel from A to B, and then calculate the total time it would take to travel from B to C, and then add these together to get the final answer. Press pause and have a go. When you're ready, press play. Joy is travelling at 50 miles per hour from A to B. So this is the calculation for that section, and it takes her 30 minutes. She's travelling at 40 miles per hour from B to C. So here's the calculation for that, and it takes her 37.5 minutes. So the total time is 67.5 minutes, or you can say it's 1 hour, 7.5 minutes. This is a distance time graph which shows Tom's journey on his bicycle. Whenever I see a distance time graph, the first thing I do is look at the horizontal axis here. This is 1 p.m. and this is 2 p.m. So that means that here we've got 1:30 and this is 1:15. So each square at the bottom is 15 minutes. I might need this later on. The first thing I'm asked is at what time did he begin to rest? If I look at the graph, I can see I've got movement here, here, and here. This part of the graph is the rest because the time is continuing, but Tom isn't getting any further away from home. I want to know what time he began to rest, so that's here, and it's 1:30 p.m. Now I want to know how long he rested for. He rested here for 2 squares, and I know that 1 square is 15 minutes, so this must be 30 minutes. In the next part, I'm asked how far did he go in the next 15 minutes after his rest. So that starts here when he started moving again after his rest, and that's at 2 p.m. And I know that 15 minutes is 1 square, so I'm looking to here. At 2 p.m, he was 3 kilometres away from home, and at 2:15, he was 5 kilometres away from home. So in that 15-minute period, he travelled 2 kilometres. Now, how far was he from home at 3 p.m? I find 3 p.m. on the time scale, that's here, go straight up to the graph, and then straight across. And I can see he was 11 kilometres away from home. Now I want to know how long it took him to get home. This is the point on the graph where he turns around and starts moving back towards his home. So he turned around at 3 p.m. and he arrived back at home at 4 p.m. So it took him 1 hour to get home. I now want to know what speed in kilometres per hour he travelled at to get home. This part of the graph shows his journey home, and we know that it took him 1 hour to travel home, and the distance he travelled was 11 kilometres. So he must have been travelling at 11 kilometres per hour. Unfortunately, it's not always this easy to work out the speed because we're not always given one nice neat hour. For instance, here I'm being asked what speed is shown by the line, but the line doesn't travel for a whole hour. Why don't you try it first? Press pause and see if you can work out what speed this line is showing. When you're ready, press play. Now it's important to realise that you don't actually have to travel for a full hour to get a speed in kilometres per hour. This line shows a journey that only lasts for half an hour, and in that time it goes 4 kilometres. So we have 4 kilometres in 30 minutes. To turn this into a speed in kilometres per hour, we need to double the 30 minutes to get 60 minutes, which is an hour. If I've doubled this, I'm going to have to double this too, so I get 8 kilometres. So travelling at this speed, you would travel for 8 kilometres in 60 minutes, so it must be a speed of 8 kilometres an hour. Here's a harder one for you to try. Press pause and have a go. When you're ready, press play. For this one, I don't want to try and use the whole line because it ends here in the middle of a square and it's difficult to tell what time that is. So what I need to do is find a convenient point. That would be here where it crosses over the corners of a square. So using this point, I can see that in one square, which is 15 minutes, it's travelled 4 kilometres. So we have 4 kilometres in 15 minutes. I need to multiply this by 4 to get an hour. So I multiply this by 4 as well and get 16 kilometres. So the speed is 16 kilometres per hour. Now try this one. Press pause and have a go. When you're ready, press play. Now this time, the fact that the line is going this way instead of this way doesn't affect the speed. It's just telling us that the direction has changed and we're coming home. Again, I'm going to find a convenient point where it crosses over a square nicely, and that's here. And we're travelling for 30 minutes, and we're travelling a distance of 5 kilometres. So we've got 5 kilometres in 30 minutes. And I can double this to get the speed per hour. So it's 10 kilometres. So the speed is 10 kilometres per hour. Here's a full question for you to try now. Before you start, you'll need to copy the graph out carefully onto some squared paper. Although I haven't shown you how to do something like question C, you've learnt enough about speed to be able to do this part. Press pause and have a go. When you're ready, press play. Here are the answers. I'm going to show you how I got the answers to part C and part D. So for part C, I know that Sam travelled home at a speed of 20 kilometres per hour. So the first thing I need to do is decide what an hour is on the axis here. An hour is 2 squares. So he started travelling home here, and 1 hour looks like this. He was travelling at 20 kilometres per hour. So in this amount of time, he must have travelled 20 kilometres towards home. So he started 50 kilometres away from home, travelling 20 kilometres will mean that he's now 30 kilometres away from home. I've now got to draw a line which shows him travelling this distance in this time. The line would look like this. Now, using a ruler, I need to extend this line until I reach the axis. This finishes off the graph, and we can see that Sam gets home at 6 p.m. Here's your final question. This time you need to draw the graph yourself. You'll need some graph paper. Begin by copying out the axes and then follow the instructions up here to draw the distance time graph. Press pause and have a go. When you're ready, press play. This is what your finished graph should look like. These two shapes here are mathematically similar. What that means is that the bigger one is an enlargement of the smaller one. Whenever we have an enlargement, we have a scale factor. We can find the scale factor like this. It looks really complicated, but all it means is that if I was told that this side here was 2 centimetres long, and this side was 6 centimetres long, then to find the scale factor of the enlargement, I would do the 6 divided by the 2, and that gives me 3. So I know that to get from this shape to this shape, I always multiply by 3. To go the other way, I divide by 3. So for example, if I was told that this was 4 centimetres long, I would multiply it by 3 to find this corresponding side here, and that would be 12 centimetres long. If I was told that this side here was 15 centimetres long, then to find this corresponding side, I could divide by 3, and that would give me 5 centimetres. Out of interest, although the lengths of the sides are all 3 times bigger on the larger shape, if you compare two angles, they are actually exactly the same. So the sides get bigger, but all of the angles in the shape stay the same. So using what I've just shown you, you should now be able to find the lengths of sides X and Y. You can use a calculator to do this. Press pause and have a go at it. When you're ready for the answers, press play. So I'm hoping that you started by using these two corresponding sides to find the scale factor. So we've got 9 divided by 6, which is 1.5. So to go this way, we multiply by 1.5, and this way, we divide by 1.5. Now to find x, the corresponding side is here, so I have 7 times 1.5. 7 times 1.5 is 10.5. So x is 10.5 centimetres long. For y, the corresponding side is here. So I've got 12 divided by 1.5. 12 divided by 1.5 gives me 8. So y is 8 centimetres long. This is an exam type question for you now. A calculator can be used for this. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is another typical exam question, but this time it's a similar shapes question in disguise. If you look closely at the diagram, you should be able to see a small triangle here and a larger triangle here. The two triangles are similar, and I draw them out like this to help me with the working out. I can put on the lengths from the original picture over here. There's just one that I need to do a bit of working out for. The length AC here is the 18 plus the 4.5. So the big length AC here is 22.5 centimetres. Because I've now got two similar triangles, I'm going to work out the scale factor. So the corresponding sides are the 18 and the 22.5. So the scale factor is 22.5 divided by 18, and this gives me 1.25. So I multiply by 1.25, and I can also divide by 1.25. Now that I know the scale factor, I'm ready to look at the question. I'm asked to calculate the length of ED. That's this length here. So to find that, I need to find the length of AD and then take away 12. So to find AD, I know the corresponding side is 12 and I need to multiply this by 1.25. So 12 times 1.25 is 15. So the length AD is 15 centimetres. Remember, we're looking for ED though, so I need to do the 15, take away the 12, and 15 take away 12 is 3 centimetres. In the second part, I want to find the length of BE. That's this here. I've got the corresponding side, it's 14, and I just need to divide by 1.25. 14 divided by 1.25 gives me 11.2. So the length of BE is 11.2 centimetres. Here's a question for you to try. In the first part of the question, you want to find the length of CD, which is straightforward. But in the second part, you want to find the perimeter of the trapezium EBCD. So you're looking for this total length here. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For the second part, we were given this length, that's 10, and this length, which is 9.6. We'd worked out this in the first part, that's 18, so we needed to work out BC. The working out for that is here, and BC is 7.2. To get the perimeter of the trapezium, we add all those together and get 44.8 centimetres. Here's your final difficult exam question. In this question, you're being asked to find this area here. There are at least 3 different ways of doing this, but they all involve using similar shapes. Press pause and have a go. When you're ready for the answer, press play. No matter which method you use, your first step should be to find the length of EC, and that's 16.5 centimetres. You might have chosen to use the formula for the area of a trapezium. You would get this answer here, 55 centimetres squared. Alternatively, you might have split the trapezium up into a rectangle and a right-angled triangle. Again, you get 55 centimetres squared for the area. Or you might have decided that to find this area, you can do the big triangle's area, take away the small triangle's area. The working out would look like this, and you get 55 centimetres squared again. This is a compound interest question. Compound interest is quite special, and it means that you earn interest on your interest. Tim puts £6,000 into an account. It pays compound interest at a rate of 2.4% per annum. This just means per year. We want to know how much is in the account after 3 years. This would be a calculator question. Let's look how this works. If Tim put the money in the account for just 1 year, he would earn 2.4% of £6,000 in interest. So that's 2.4 divided by 100 times 6,000. I can do this in a calculator and I get £144. So that's the amount of interest he's earned in the first year. It would be added on to the money. So at the end of 1 year, he would have £6,144 in the account. Now for the second year, he would earn 2.4% of £6,144. And this gives us 147.456. I'm not going to round it off yet because I'm not at the end of the question. This would be added on to the £6,144. To give 6291.456. In the third year, he would earn 2.4% of this amount of money, which gives 150.994944, and this would be added on to this. Now at this stage, because I'm in the third year, I'm going to round off the answer. Because this is money, it's appropriate to round it to 2 decimal places. So we have £6,442.45. This is the amount of money that's in the account after 3 years. Now this does work, but can you imagine if he left the money in the account for 10 years? You'd have lots and lots of working, and quite frankly, it would take ages. So instead, there is actually a faster way that we can do it. To do this, we say to ourselves, everything starts off at 100%. We're earning 2.4% interest per annum, so we're going to add that on. And that gives us 102.4%. Now we want this percentage as a decimal to be able to use it in our calculator. So what we do is divide it by 100. And that's 1.024. This gives us our multiplier, and this is really important for the question. What we do now is get the amount of money times the multiplier to the power of the number of years. So this one is to the power of 3. We can type this directly into our calculator, and then rounding to 2 decimal places, we immediately get the answer 6,442.45. So this is the amount of money he's got in his account after 3 years. So there are 2 methods for calculating compound interest. You can take your pick which one you want to use, but I know which one I prefer. Here's a question for you to try now. Remember to use a calculator to help you with this. Press pause and have a go. When you're ready, press play. Here's the answer. You'll notice I've only shown you the faster method because this is the one that I really recommend you try to use. Here's another question for you to try. This one's got a slight change in it. You're being asked how much interest she's earned after 9 years. Press pause and have a go. When you're ready, press play. Here's the answer. First of all, I worked out the amount of money that was in the account at the end of 9 years, and then took off the original amount of money she invested to give me the amount of interest earned. So this is the final answer. Now in this question, we're being asked about depreciation. This means losing money as the years go on. We actually work it out in a very similar way to compound interest. So we say everything starts off at 100%. The car is losing 29% of its value per year. Because it's losing this value, we take it away. That gives us 71%. We want this as a decimal, so we divide it by 100. And we get 0.71. Now the car cost £15,000, so that's the money. We multiply it by the multiplier, that's 0.71, to the power of the number of years, which is 3. Again, we can use a calculator and round to 2 decimal places. We get 5368 0.67. So at the end of 3 years, the car is worth £5,368.67. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you. This one looks similar to the last one, but there's a slight change. This time you're asked, how much will it have devalued by at the end of 6 years? What this means is how much money will it actually have lost off its original price. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, you needed to work out the value of the caravan after 6 years, and then subtract this from the original price to work out how much money it's lost in total. This is the answer you should have got. Now this question looks much more difficult because we've got an X here, but let's read it through. It says that X pounds was invested for 9 years. It earned compound interest and we've got the rate here, and at the end of the 9 years the amount of money in the bank was this. We want to work out how much we started out with. We actually do this in a very similar way. So we have 100% to start off with, and we're adding on 2.4% each year. So that's 102.4%. We need this as a decimal, so 102.4 divided by 100 is 1.024. Now we usually have our money, but this time our money is X, multiplied by this multiplier, 1.024, to the power of the number of years, which is 9. And that will equal this here, so that's 20,426.01. Now to work out X, I can divide both sides by this. So X is going to equal 20426.01 divided by 1.024 to the power of 9. I can use a calculator to get this answer, and I get 16,500.00 rounded to the nearest penny. So the value of the investment was £16,500. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this question, I can see that I'll be dealing with ratios between 3 numbers, representing Amy, Bill and Kim. The first thing I'm going to do is set up my headings. So we've got A for Amy, B for Bill and K for Kim. Amy's score was 6 times Bill's score. So if Bill scores 1, Amy must score 6. Kim's score is a third of Amy's score, so we divide this by 3 to get 2. I'm asked to write the ratio of Amy's score to Bill's score to Kim's score, and that's this here. I can just put my ratio symbols in. So the answer is 6 to 1 to 2. Here's a question for you to try. Press pause and have a go. When you're ready for the answer, press play. So this time our headings are A, B and C. Ant's score is 8 times Ben's score, so if Ben is 1, Ant is 8. Carl's score is half of Ant's score, so we divide this by 2 to get 4. So the answer is 8 to 1 to 4. Here's another question for you. Because it says give your answer in its simplest form, remember that your final answer must be whole numbers which can't be simplified. Press pause and have a go. When you're ready for the answer, press play. So again, we have Ant, Ben and Carl. Ben's score is 5 times Ant's score. So if Ant scores 1, Ben scores 5. Carl's score is half of Ben's score. So we half this and get 2.5. Now, we might think we're finished here, but this isn't in its simplest form because we've got 2.5 here. We need to get whole numbers, so what I'm going to do is double each of these numbers. So doubling this gives me 2, this gives me 10, and this gives me 5. This will be my answer, 2 to 10 to 5. Here's the next question that we're going to look at. Press pause and read it through. When you're ready for me to carry on, press play. So this time, although my final answer is going to be a ratio between two numbers, I'm actually going to start with a ratio between three numbers: women, men, and children. So my headings are going to be W, M, and C. We're told there are 120 people in a choir and that a third of them are women. A third of 120 is 40, so we know there are 40 women. The number of women in the choir is 4 times the number of men in the choir, so the number of men must be 10, because 4 times 10 is 40. I'm then told the rest of the people are children. We've got 50 people so far, and there are 120 in total, so the number of children must be 70. The question asks about the number of children to the number of men. So now we want new headings, children and men. We know that the number of children is 70 and the number of men is 10. The question wants this in the form n to 1. So I need to get this number to 1. To do that, I would divide by 10. I have to do the same thing to this number as well. So 70 divided by 10 is 7, and 10 divided by 10 is 1. Finally, the question's asking for the value of n. We know that's 7, so we can write n equals 7. Here's a question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. In this question, I'm told that the ratio A to B is 2 to 5, and the ratio A to C is 6 to 1, and I'm asked to find how many times bigger B is than C. So what I'm going to try to do is combine these two ratios into one ratio, but between three things. So I've got A, B, and C. I know the ratio A to B is 2 to 5, so I can put those in here. And I know the ratio A to C is 6 to 1, so I'm going to put those underneath. A is 6, C is 1. Now I want to get all of these numbers into one ratio between A, B and C. I can see I've only got one number in the B column and I've only got one number in the C column, but I've got 2 in the A column, so this is the key to the whole thing. What number will 2 and 6 both go into? Well, they'll both go into 6, so that's going to be my number for the A column. This one's already 6, but this one needs to be multiplied by 3 to make 6. Remember, you can multiply any ratio by any number and keep the same ratio. So 2 times 3 is 6, 5 times 3 is 15. This number was already 6, so this one doesn't need to be multiplied by anything, so that can just go there. So the ratio is 6 to 15 to 1. Now always make sure you actually answer the question you're being asked. I'm being asked how many times bigger is B than C. When C is 1, B is 15, so B is 15 times bigger. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. This is a similar type of question. Again, I'm going to set up my headings. This time I've got E, F and G. The ratio E to F is 3 to 7 and the ratio F to G is 5 to 6. This time I can see I've got two numbers in the F column and I need to find something that these will both go into. Well, if I multiply 7 by 5, I get 35, and if I multiply 5 by 7, I get 35 as well. Remember this trick because it will always work for you. So now I can multiply this whole line by 5, giving me 15 and 35. And I can multiply this line by 7, giving me 35, which I've already got, and 42. So my ratio is 15 to 35 to 42. The question asks me to work out the ratio E to G. So my headings are E and G. E is 15 and G is 42. So this is my ratio, but it asks for the simplest form. I can divide both of these numbers by 3. That will give me 5 to 14. This is the final answer. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. There's a lot of words in this question, but I can see once again I've got a ratio between three things: blue, green and red pens. So I'm going to set up my headings: blue, green and red. The ratio of blue to green is 1 to 4, so I've got 1 to 4 here. And the ratio of green to red is 3 to 5, so I've got 3 to 5 here. So here are my common numbers. I can multiply this one by 3 and this one by 4. So multiplying by 3 gives me 3 and 12, and multiplying by 4 gives me 12, which I've already got, and 20. So here's my ratio, 3 to 12 to 20. I'm told there are less than 110 pens in the box, and I'm asked what's the greatest possible number of blue pens. If I add these together, I get 35. So there could be 35 pens in total in the box. But is this going to give me the greatest possible number of blue pens? No, because I could double this and have 70 pens, and the ratio would still be the same. Remember, I'm told there are less than 110. Let's add another 35 on. I get 105, so there could be 105 pens in the box. If I add another 35 pens on, I get 140. Now that's too many because I'm told there's less than 110. So there must be 105 pens in the box for me to have the greatest possible number of blue pens. 105 is 3 lots of 35. So I've multiplied each of these numbers by 3. So I've got 9 blue pens, 36 green pens, and 60 red pens. So the answer to the question is that the greatest possible number of blue pens is 9. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready, press play. So I've started this question in the usual way with my 3 headings, and I've worked out that we've got the ratio 18 to 10 to 7. I'm told there are 63 bungalows in the village, so we've got 63 here. Now what do we multiply 7 by to get 63? We multiply that by 9. I'm asked how many houses there are in the village, so I've got to multiply this by 9 as well. 18 times 9 is 162. So there are 162 houses in the village. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Our headings this time are A, B, and C. We have A to B is 3 to 2, and B to C is 6 to 5. So I can see if I times this by 3, I'm going to get 6. So I'm going to times all of this by 3 and get 9 and 6. This is already 6, so this is 5. So this is my ratio. I'm told that Team B has won 12 games. So this must be multiplied by 2. Multiplying this by 2 gives me 18, and multiplying this by 2 gives me 10. I'm asked in total how many games have the 3 teams won, and I can get that by adding this up. 18 plus 12 plus 10 is 40 games. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. This is a tricky looking question because we've got some fractions here. Before we begin, let's have a quick look at a link between fractions and ratios. So here's some fruit. Let's say we have 3 bananas and 2 strawberries. What fraction of the fruit are bananas? Well, it's 3/5 because we've got 3 bananas out of 5 fruits altogether. What's the ratio of bananas to pieces of fruit? This time it's 3 to 5 because we've got 3 bananas and 5 pieces of fruit altogether. We can now use this idea to write our fractions as ratios. So we can write A to B is equal to 3 to 7, and B to C is equal to 4 to 5. Now I want to find A to B to C. So I set up my 3 headings, A, B, C. A to B is 3 to 7. B to C is 4 to 5. I can times this by 4 and this by 7. So I get 12, 28, and this multiplied by 7 is 35. So this is the answer. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. In this question, I'm being asked to make an equation from a ratio. To make it easier to see which of these equations is the right one, I'm going to represent this ratio as a picture. So we have the ratio A to B is 6 to 1. So I've drawn this 6 lines for A and 1 line for B. I can now see that A is 6 times longer than B, so A must be 6B. So this is the correct equation. Here's a harder one. Once again, I'm going to use pictures to help. So we have the ratio A to B is 5 to 3. So I've drawn 5 lines for A and 3 lines for B. What I really want to do is make these the same length. So if I multiply this by 3 and this by 5, I get this. And you can see that they're the same length. We've got 3A here and 5B here. So I can now see that 3A must be equal to 5B. Here's another one. This is the last one I'm going to draw a picture for. So here I've got the ratio A to B is 2 to 7. So I draw my picture, 2 lines for A, 7 lines for B. If I want to make these the same length, what I'd have to do is multiply this one by 7 and this one by 2. so I would have 7a and 2b. So my equation is 7a is equal to 2b. So in general then, the ratio a to b being equal to the ratio x to y will give me the equation ya equals xb. I always remember it as you multiply the outers together to get the first part and the inners together to get the second part. You can see that here. Multiply the outers, we get 7a. Multiply the inners, we get 2b. Multiply the outers, we get 3a. Multiply the inners, we get 5b. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at direct and inverse proportion. Remember, proportion means a certain type of relationship between two quantities. If two things are in direct proportion, then as one of them increases, the other also increases. Typical graphs for direct proportion would look like this. For example, some people's pay is in direct proportion to the number of hours they work. As they work more hours, their pay increases. If two quantities are inversely proportional to one another, then as one thing increases, the other thing decreases. A typical graph would look like this. A typical example would be thinking about moving away from a light source. As the distance from the light source increases, then the brightness of the light seen decreases. Here are 3 typical exam questions. If we look at them, we'll notice that they all have something in common. They all tell you that the things are proportional. Here it says directly proportional. Here it just says proportional, and if it says this, then you can assume that it's direct proportion. And here it says inversely proportional. So these questions are easy to spot on an exam. Let's have a look at how we tackle this kind of question now. The first line tells us that y is directly proportional to x. So we can write y, x, and there's a special sign that goes in between them for proportion. It looks like this. Now this isn't an infinity sign, notice that it's open at this end. Whenever you see this sign, you can swap it for equals k, where k is going to be a constant, and we keep the x on the end there. So we now have y equals kx, so y is something times x. Now this is the only difficult part of proportion questions. Once you've written this line and swapped the proportion symbol for equals k, the rest of it is as straightforward as this. I'm told that y is 28, so I'm going to change the y for 28. And I'm told that x equals 7, so I'm going to change the x for 7. Now remember, kx means k times x, and I know that x is 7. Now I can divide both sides by 7 to find out what k is. So I've got 28 over 7 equals k, and that tells me that k is equal to 4. We call this the constant of proportionality, and now that I've worked it out, I can use it to write an equation connecting y and x. I use this line here to help me do this. So from this line, I get that y equals k, which I know is 4, x. So this is the equation connecting y and x. Let's look at this question now. It starts with y is proportional to. So as soon as I see that, I can write y with my proportion symbol. I'm told it's proportional to the square of x. So that means x squared. Remember, whenever you have this symbol, you can replace it with equals k. So we've got y equals kx squared. Now y is equal to 5, so I can put that here. And x is equal to 4, so I've got k times 4 squared. So 5 is equal to k times 4 squared, which is 16. Now to find k, I can divide both sides by 16. So I've got 5 over 16 equals k. Now I can use this and this line to give me an equation linking y and x. So I've got y equals k, which is 5/16, and then x squared. Now I've got my equation linking x and y. But if you look at the question, you'll notice that although in this first one it asked me for that equation, in this second one it actually doesn't. I still have to work it out though, because I'm being asked to find the value of y when x equals 8, and I'm going to have to use this equation to help me do this part. So to find the value of y when x equals 8, I'm going to substitute 8 for x in this equation. So y equals 5/16 times by 8 squared. So y is 5/16 times 64. I can now see that 16 goes into 16 and into 64, so I can cancel. 16 goes into 16 once, and it goes into 64 4 times. So I've got 5 over 1 times 4. Now that's the same as 5 times 4, so y is 20. And this is the value of y when x equals 8, so I've now answered the question that I'm being asked. Now in this final question, I'm told that y is inversely proportional to x. I start by writing this very similarly, y and then the proportion sign. But for the inverse bit, I've got to put 1 over x instead of just x. This is how we write something when it says it's inversely proportional. Now remember, we can replace this symbol with equals k, and that looks slightly different here as well. We have y equals k over x. That's the hard bit done. Now we're going to start substituting. So I'm told that x is 2 and I'm told that y is 6. So I've got 6 equals k over 2. I can now multiply both sides by 2 to find k. So 6 times 2 equals k, and that tells me that k must be 12. Now using this line, I can write my equation. Y equals k, which is 12, over x. Notice again that the question doesn't actually ask me to find the equation, but I've got to do it to be able to answer this part here. Find the value of y when x equals 4. So I'm now going to put x equals 4 into this equation. So y equals 12 over 4. And 12 divided by 4 is 3, so y is equal to 3. Here's a question for you to try now. Press pause and have a go at it. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Don't let the fact that the letters aren't x and y put you off. You still set it up in the same way, but you're going to be using D and S. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a question in context. You'll still be using the same skills that you've used so far in this clip. You are allowed to use a calculator for this question. Press pause and have a go. When you're ready, press play. Here's the answer. When you read this question, you'll see that it says that t is proportional to the square root of a. So your first line should look like this. Don't be put off, you just need a square root on it, and then you carry on in the usual way. Now here's a different type of question for you. With all the skills you've learnt in this clip, you should be able to answer it. There's actually no calculation involved this time. You just need to match up each of these equations here with the correct statement. Press pause and have a go. When you're ready, press play. Here are the answers. So for this question, we're going to set out our headings in the normal way. So we've got almonds, cashews, cashews and peanuts. So we've got almonds, cashews and peanuts. The ratio of almonds to cashews is 2 to 3. And cashews to peanuts is 5 to 8. So we have two numbers in this column. 3 and 5 will both go into 15 if I multiply this by 5 and this by 3. So 2 times 5 is 10 and 8 times 3 is 24. So this is the ratio we're working with, 10 to 15 to 24. I'm told the total number of nuts in the box is 1,372 and I want to work out the number of cashews. So I need to add these up. 10 plus 15 plus 24 is 49. I now need to do 1,372 divided by that 49, which gives me 28. To work out the number of cashews in the box, I want to do 28 multiplied by the ratio for cashews, which is 15. 28 multiplied by 15 is 420. So the answer is 420 cashews. Here's a question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. To start this question, I set out my headings, blue, green and white. And then this line says there are 5 times as many blue discs as green discs. So I put in 1 for green and then 5 for blue. You can then continue the question in the usual way. In this question, I'm told I've got a straight line with 4 points lying on it in order. To answer this tricky question, I need to notice that the line goes from A to D, and here it's been split into 5 parts in total, 1 plus 4, whilst here it's been split into 15 parts in total, 7 plus 8. So I can show this in a diagram. Now to make any comparison, I need to have the same amount of parts here as I have here. I know that 5 goes into 15 3 times, so I can multiply this by 3. If I multiply this by 3, I get the ratio 3 to 12, and that gives me a total of 15 parts. I've now got the same amount of parts in each line, so I can start comparing. So here is my line AD. I know that B and C are 2 points on this line somewhere. I'm going to use the first ratio to locate B. I know that AB to BD is 3 to 12. So B is probably about here. This would be 3 parts and this would be 12 parts. I can now use this ratio to work out where C is. I know that AC to CD is 7 to 8. So C is going to be about here. This is 7 and this is 8. Remember, I want to work out AB to BC to CD. Well, I know AB is 3 and I know that CD is 8. To find BC, we can either do 7 take away 3, which is 4, or 12 take away 8, which is also 4. So we know that BC is 4. So this is our final answer. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this question, I'm told that this ratio is equivalent to this ratio, and I'm being asked to show this. Now we're going to use something to help us do this that we've learnt in the previous ratio clip, which is that if we have two ratios like this, which are equivalent to or equal to one another, we can form an equation from the ratios. And we can do this by multiplying the outers together. That gives us YA, and this is equal to what you get if you multiply the inners together, which is XB. So we've turned our equation with ratios into an equation without ratios. So I'm going to use this on this here. I know that this is equivalent to this. So I can multiply the outers and get 2 multiplied by y plus x. And that's equal to the inners multiplied. So that's k multiplied by y minus x. Multiplying these out gives me 2y plus 2x equals ky minus kx. Looking at this, I can see that I want to isolate the y. So I'm going to take ky away from both sides. That gives me 2y plus 2x minus ky equals minus kx. Now I'm going to subtract 2x from both sides. So that's 2y minus ky equals minus kx minus 2x. Now I'm going to factorise both sides. So here I get y, 2 minus k, and here I get x minus k minus 2. Now I can divide both sides by 2 minus k. So I get y equals x brackets minus k minus 2 divided by 2 minus k. So now I've isolated the y. If I just compare what I've got with what's given here, I can see it's pretty close, but I just need to do one more thing. I need to multiply the top and the bottom by minus 1. This will give me y equals x brackets k plus 2 divided by k minus 2. So I've now shown, with full algebraic working out, that y is equal to this. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. So I start this one in the usual way. 2 times this, here, and 1 times this is here. I can then make a quadratic equation, which I can factorise. Once I've factorised, I can then quickly find the two values of x. In this question, I'm told that a bag contains only red and yellow counters, and the ratio of red to yellow is 3 to 4. I'm then told if 7 of the red counters are removed, the ratio of red to yellow is now 2 to 3. The question asks how many yellow counters are in the bag. Now this looks like a really horrible question, but I'm going to show you 2 different ways of doing it. The first way is to say that the ratio of red to yellow counters is 3 to 4. And I can change this equation with ratios into an equation without ratios. Remember, we write 4r equals 3y. Then, if I take 7 of the red counters away, that's r minus 7, and the ratio of that to yellow is now 2 to 3. And again, I can make an equation without ratios. 3 multiplied by this, that's 3r minus 21, is equal to 2 multiplied by this, 2y. I've now got two simultaneous equations, and I can solve them to find the number of yellow counters. So I've now solved my simultaneous equations by multiplying this one by 3 and this one by 4 to get this, and then subtracting this from this to give me 84 equals y. So using this method, I know the number of yellow counters is 84. For the second method I'm going to show you, we set up our headings, red and yellow. I've got my ratio 3 to 4. Now remember, this doesn't necessarily mean that we have exactly 3 red counters and 4 yellow counters. It means we've got a multiple of 3 red counters and the same multiple of 4 yellow counters. So I'm going to call this 3x and 4x to represent the multiples. Now, if 7 red counters are removed, that's going to give me 3x minus 7. And this, to 4x, is equal to this ratio, 2 to 3. From this, I can make an equation without ratios. 3 multiplied by 3x minus 7 is 9x minus 21, and 2 multiplied by 4x is 8x. I can now solve this equation. So solving this equation gives me that x is equal to 21. Remember, this isn't the answer. This is the multiple. I want to know how many yellow counters are in the bag. It's 4x and x is 21. So it's actually 4 times 21, which is 84. And we can see that we have the same answer as we got using the other method. Here's a question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer using both of the methods that I've shown you. There are 24 yellow counters in the bag. Here's another difficult question for you to try. Press pause and have a go. When you're ready for the answer, press play. So for this one, I start with subtract 6 from p, so that's p minus 6, and subtract 6 from q, so that's q minus 6. These are in the ratio 11 to 1, so I get this line. I can use my usual technique, 1 multiplied by this is this, 11 multiplied by this is this. And from this, I can get that p is equal to 11q minus 60. Now I go to this part and I do a similar thing and get p equals 3q plus 36. So now I've got two equations for p. So I now know that 11q minus 60 is equal to 3q plus 36. I can solve this to find q, which is 12. Now that I know that q is 12, I can choose one of these two to calculate p. This one looks easier, so I'm going to use this one. Substituting in q equals 12 gives me that p is 72. The question asks for the ratio p to q. So p to q is here. Make sure you get the numbers the right way round. P is 72, q is 12, and then I need it in its simplest form, so I divide by 12 to get 6 to 1. Here's another one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. This looks like a nice, short, easy little question. However, The examiner's report for a question just like this stated that the great majority of students gave the answer as 5 to 3, which is actually incorrect. The actual answer is 3 to 5. And we can check this because we know that if we multiply the outers together, we get 5p, which is here, and multiply the inners together, we get 3q, which is here. So for this question, the answer must be 2 to 5. With a quick check, multiply the outers, 5x, perfect. Multiply the inners, 2y, perfect. For this one, it must be 7 to 1. Quick check again, outers, 1x, which is x, inners, 7y. Here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are two questions for you to try. For this one here, you'll probably want to collect like terms together before you begin. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you to try. This one's pretty difficult, so take your time over it. Press pause and have a go. When you're ready, press play. So the first line tells us B is 4/5 of C. So we have B is equal to 4/5 of C. From this line, I can get that the ratio B to C is 4/5 to 1. Now looking at the question, the final answer needs to be integers. So I'm going to multiply both of these by 5 to make integers. That will be 4 and that will be 5. I also know that 3a is equal to 2c, so this gives me the ratio a to c equals 2 to 3. And this one's already integers. Now I can set up my three headings, A, B, C. I know that B to C is 4 to 5, and A to C is 2 to 3. I've got two numbers here, they'll both go into 15 if I multiply this by 3 and this by 5. So multiplying this by 3 gives me 12, and multiplying this by 5 gives me 10. So my final ratio is 10 to 12 to 15. These numbers are all integers, and this ratio can't be simplified anymore, so this is the final answer. Here's another one of those for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer.